Hi everyone, it's Monday the 11th of April 2022, back in the workshop. Clocks have changed. We're at that slightly odd time of year when it's actually warmer inside the house than out of it. Hopefully everything will get nice and toasty soon and we can start gluing again. But it's getting to the point where I can't ignore the fact that I'm going to have to start using my sander that I was building, and to use it I'm going to have to finish it. So this is the sander, or it will be. It's my washing machine based implementation, and to get that working I need to control this, which is a universal motor. And to do that I've built this, which is hopefully a universal motor controller, or not if it doesn't work. So I'm going to, I've just realised I've mislaid my notebook. I'm going to go and find that so I can talk through how this kind of works. There's two channels that give a much better treatment of this than I'm about to. One of them is called Flowering Elbow, and the other one is called the Post-Apocalyptic Inventor. They've both done very good videos about how these work and why you need to use one of these to control them. I mean, in principle, as far as I understand it, if you connected this motor directly to, so these run off either AC or DC, I believe, but if you apply an AC mains input to this motor, it will essentially run away. It will just increase its RPM without limit until it reaches some sort of mechanical limit, which I imagine at some point it will reach some kind of equilibrium condition, but it will be going so fast that I'm sure these bearings would start to overheat and the whole thing would that'd be a bad time and not great for the longevity of whatever you've attached it to. This device uses a triac, which is controlled by a small capacitor and resistor network, which effectively chops up the AC voltage that you're delivering to this, so you're not getting the full cycle in each direction, you're just getting a part of it, and that limits the amount of power that is put into the motor and limits the speed that it's going to reach. That's the theory. So I'll find my notebook and then I'll come back in quickly and we'll see where we are then. Right, so I found my notebook. It was here the whole time, and also done a little bit of YouTube watching to just refresh my memory on how I think this might be working. So in essence, this motor, I think we're going to use it as a series wound induction motor. So the AC is going to go straight into the field windings, and then come out of the field windings and go through this, come out of the field windings into the armature, and then ultimately down to neutral. So essentially it goes electricity in, field windings for the motor, through the armature, and then down to neutral. Okay, now, so that being the case, the essentially the power goes through here, through the field windings, through the armature, back here, and then this is what regulates the amount of power there is in the actual AC waveform that passes through this system. That is the way that I'm interpreting this. but I may have to go and have another thing. I just don't want to produce some kind of a dead short circuit anywhere. Live field, out of the armature, back into here, down to neutral. I think that's the way it's going to work. It's not 100% clear from what I've looked at on YouTube yet. From this particular circuit diagram, I may do a little bit more revision in a moment and see if I can just make sure I'm right. I have set this up now, I think, to be that thing. Confusingly, that is that, that is that. No, sorry, that is that. Neutral is down here, and the live and the field. Oh no, have I buggered this? Oh god, this is too good, confusing. I'm confusing myself now. I'll come back to it. Hang on. Right, so I think I've got this right now. I've managed to solder this together every incorrect possible way available, which is why it looks a bit gruesome. Actually, it doesn't look too bad on camera, but that bit in the middle of shot now was a bit of a nightmare. Anyway, so yeah, so just turn it around. So live and field is actually that one and that one. So power come in here, go out through the field, into the field, come out of the field, go through the armature and into here, and then from here it will be being regulated by the triac before it finally is allowed to flow out through the neutral. So this will be regulating, essentially regulating the flow of the electricity. Flow is probably not the right word, but we won't get into that, that's philosophy. Through the field armature series wound induction motor arrangement, then out to ground, not ground, neutral, and equally back through the armature, through the field and out when the electricity is wiggling the other way. So I think that's it. So I just need to wire it up to the motor here. This is the armature, grey and black. Now the field is interesting. I measured the resistance between these three wires. The blue one, blue to brown and blue to red, is 1 ohm, or 1 ohm. Brown to red is 1.8. So they all seem to connect together to each other. I think the blue one is a center tap, is a tap on the coils, and the brown and the red are the actual full coil. So we can but try, I guess. I'm not sure how big a bang this is going to make, so I'm going to try and set up something where I can switch it on from a reasonable distance away using an extension lead, and that way I can be hopefully out of the firing line, just in case everything goes kaboom. But yeah, I'll have to get this, I'll get this wired up and then bring it back in then. Just trying to work out whether I want to do this tonight, because it's getting quite late now. But I kind of don't want to. I want to see if I can get it to work. Let's see what I can do. Let's see if I can get it wired up. Okay, so I think I got it sorted. I've got my extension lead here, power coming in, live that's bridged across to here, goes out into the field windings, out of the field winding on the brown, that's in the way, into the brushes, the armature, on that blue bridging. Quite, this bloody thing's annoying me. Out on the purple. Back in here. And then through the thyristor, which is this, and then out to neutral. And the thyristor is being controlled by this network of capacitors and resistors, which is doing the kind of voltage chopping. Okay, so that's that. And nothing's got nothing to short the back of that. Motor's over here. That's over there. I'm going to be over here, operating that there. So I'll plug that in. I'm just going to, so that's plugged in. I'm going to, so I can control it from here, turn it on, turn it off. All right. I'm just going to put some ear protection and eye protection on. Then we'll do it. Okay, hold on one second. Okay, I've got my ear and my eye protection on. That's all there. If I turn it on, and we'll see if all the lights go out. 3, 2, 1. Whoa, okay. That sounded good. Sounds a little bit like it's running out of control. Okay, so everything is live when that is on. So I'm gonna unplug that. I'm gonna turn this right down to see if I can. I'll turn it right all the way one way. Nothing's blown up yet, so. Oh, that sounded better. Right. That's not really turning at all. I'm going to be really careful. Wow, it's working! I can't believe it, it's working. Very sensitive. I guess it's got no load on it, so because it's got no load on it, there's no bouncing, but you can hear that. Yeah, there's nothing counteracting the load. Oh, I've got to be careful here. So I think it will tend to accelerate. If I do put some load on it, I reckon it'll make a big difference to the controllability. So I'm just twiddling my little knob there, so to speak. How slow can I make it go? There you go. That's ticking over quite a nice. Wow! Unbelievable. Got to be really careful. Right, I'm going to turn it off now because I've been told that I'm probably shouting as well because of my ear defenders. I've been told that these thyristors, they really do need a lot of heat sinking. I can feel a little bit of warmth off it. I'm not going to touch it just in case there's any charge left in any of the components. I've got to do that again. I'm really enjoying this. Right, so you can see the rotor just turning over there. This is fun. Right, I just caught it there. Okay, so it's I think it's a couple of days later, or maybe a day later. I can't actually remember. I just realised I should probably record just a little bit of an outro so I can get this posted tonight, whichever day it is, Wednesday. So yeah, so next step, right, so having got over the fact that something I've built has actually worked in electronics, I haven't had a lot of success. So I'm not sure it's my natural medium, although I do enjoy it. So I'm over that now, that's good. This has got a, now I'm going to mount that on these, that needs to be on these mountings down here underneath the drum. I've got to reattach the belt, which I helpfully hung there, and then pop the pop this disc back in. It's got a woodlouse on it. Everything's got woodlouse on it in this house. So yeah, so that's got to go back inside there. I'll probably give that a quick sand just to try and get as much roundness in it as possible before I put it back. And then I'm going to come up with some kind of a way of probably using some sandpaper on some kind of a stick or something to actually run the disc and smooth it back to a consistent profile. Yeah, sorry, that probably wasn't a very good explanation. You'll see. And then yeah, mount this and put a kind of front piece on it. I haven't looked at this for a while. Need to do a sort of a wooden cardboard template for that, so that we have we can box this in, and then yeah, attach some kind of extraction to my improvised extractive device here. So yeah, so that's the next step on that project, or bit of the project. I've got all my little twiddly clamps in place for this, so yeah, so I need to do that steaming thing as well. We're just coming up on the Easter holidays, so maybe I'll manage to get it done then. Anyway, that's enough for now. I've just got to get this uploaded, and then upwards and onwards, I reckon. Have a great Easter, everyone, and speak to you on the flip side.